thanks, Ralph, for the introduction. So I'm a senior infrastructure engineer at MessageBird. So that's my official title, but I like to think about myself as a system and a MySQL expert. This talk has a little history. So I submitted this talk to SREcon 2 years ago. It was accepted, but I couldn't come. So I'm very happy that the committee accepted my talk again this year and renewed the opportunity to present you this history, this war story. So thanks to the committee, and thank you for being here. So 2 years ago, this story already happened, and 2 years ago, I was not an employee of MessageBird. I was working for Booking.com at the time, so this is something that happened then, but it has already been given to a MySQL audience. So I will start the talk with more context about MySQL, because I will not assume any knowledge from yourself about MySQL. So let's dive in. So this is the theme of the talk. We all know that human can do errors, but to really fool things up, you need a computer or a script. Remember that for the talk. So I will start with describing MySQL replication, because this is the technology that is core to this talk. We will go through the disaster from an external eyes, so the chain of event that happened. And then after that, we will dive into the explanation of why it happened, and then learning takeaways and hopefully things that you can use yourself. So typical MySQL replication deployment at Booking.com or anywhere else. We have a master here that is taking writes and potentially also serving reads requests. You would read from the master if you want the data to be the most up-to-date. And the data from the master replicates to slaves. You can have many slaves directly attached to the master. And you can also have intermediate masters that are slaves from the master, but also masters for other servers. So you want to use this if you are fanning out slaves. If you have a lot of slaves here directly connected to the master, you load the master a lot, and you prevent it from doing mastery things. So you fan out. Another reason why you might want to fan out is this here is another data center. So you don't want to go over the network many times over your WAN. And you can have many data centers here. So this and this completely applies. So you can think in terms of something that is very, very large. So Booking.com used or still use Orchestrator, I don't know. And that is a screenshot from the initial talk. We can see that this dates a little. This is MySQL 5.6. And this is the master here. It has 3 intermediate master. In this case, we can know that this is crossing a data center boundary because the line is dotted. Same thing here. This is on the same data center. And on the right, you have the number of slaves. So if you do some math here, there's 100 servers there. So this is an average size MySQL deployment. You can have much bigger, and you can obviously have much smaller. But this is interesting to see, and this is our first introduction to Orchestrator, and you will see Orchestrator is the main player in this whole story. So Orchestrator allows to visualize the replication deployment. It also allows to move things around if you want to do maintenance. And the first thing it can automatically do is replace an intermediate master. So if an intermediate master fails, you obviously want to replace it. And pseudo GTID or GTID are like MySQL magic stuff, so I won't go into details. But about an intermediate master, like those 3 servers here, if one of them fails, what will happen is that the slave of this intermediate master stop replicating. So their data starts to be stale. And we don't like that. So what Orchestrator is doing here, it will either reconnect all the boxes directly to the master, which wouldn't be good here, reconnecting 40 servers directly to the master and going through the one here wouldn't be good. Or what it will do is it will take one of those servers and promote it as the new intermediate master. And Orchestrator is able to do that mostly on its own. It needs a few configurations to do the things right, but it can do this mostly on its own. Something else that Orchestrator is able to do is to automatically replace a master in case of its failure. And when I mean replacing a master, I'm talking about this server here. So if this server fails, because it's a single point of failure for read and writes from the master, like if this server fails, I can't write anymore, or I cannot read the most up-to-date data. I can still read on the slaves, but the read from source of truth are failing. So that's not good, so we obviously want to automate this. And then Orchestrator will take one of those 3 servers and promote one of them as the new master, and then we restore service. But Orchestrator cannot do this on its own. So Booking.com used DNS to know where the master is. So the application is using DNS to connect to the master. But Orchestrator doesn't know that. Orchestrator is a service discovery agnostic tool. So what Orchestrator will do is it will call a script. Remember, script? It will call a script to do the right thing. So now we have a good overall understanding of an architecture. I'll just go a little more formal about this. And those are more recent slides and linked to other reference. So far, I've talked about failing over to a slaves. It's my favorite method of master I availability. There are others, like restoring a backup, but it's not the same time to restore. But the flip side of this is it's complicated to do. We'll see how it can go wrong. And if you want a whole discussion about this can be done, GitHub published their availability solution. GitHub will come again in the talk, and the reason I'm talking about GitHub here is that the person that is developing Orchestrator is now at GitHub. Before that, he was at Booking.com, and before that, he was at Outbrain. And he's developing this, and it's quite an interesting tool, and it's still evolving. So to formalize a little MySQL failover, the whole strategy of things, you need to have a plan of what you do. You need to decide when you do something. You need to tell your application that something happened. You hopefully protect, again, bad things, and bad things are split brain. And you need to be able to fix your data if you end up in a split brain. And those things are called failure detection, service discovery, fencing. And I'm describing that in a more recent blog post that is a follow-up post on Shlomi's post about different methods of doing service discovery. So let's quickly walk through those things. So failure detection is the first part of master I availability, and it's also a big challenge. This shouldn't be new knowledge for you. Failure detection is a very, very hard problem, and it's impossible to be 100% sure that something happened. So you need to accept that failure detection will generate false positive. All false negative, but if it's a false negative, you're probably down for longer than you want. After, you need to repoint. So repointing is the first step of failing over, and it's relatively easy. If you have the right tool, you can do it well. Orchestrator is part of those tool set that you can use. There are other things like MHA, cluster control, replication manager, and other things that can help you there. And just to be extra clear, what I mean by repointing is if you have this very simple setup one master, two slaves. If the master fails, one of the two slaves will be the new master, and you need to reconnect the other slave to the new master. If you don't do that, let's say this is your new master, and you don't reconnect this one, applications that are reading from here are not getting the good data. So this is relatively easy. It becomes a little harder if you have a lot of slaves under the master. Service discovery is the third part, and in my opinion, a very big challenge in Failover. If you centralize service discovery, it's the single point of failure. If you distribute it, you cannot update it atomically. So it's hard. And Shlomi here, this is his personal blog, described many ways of doing service discovery. So I will not go through all that. But the very important thing to understand is that because failure detection is hard and service discovery can go wrong, at some point, you might have two masters at the same time. So this is a split brain. And you don't like that, so you might want to prevent it. So this is fencing. It's a very hard problem. There are solutions, but I don't want to go into the details. There are proxies and other MySQL technology can help you. And the last thing, if you have a split brain, so if you end up writing to two places, you need to fix it at some point. And I cannot tell you how to do this because this is your data, but I can give you a tip at the end of the talk how to do that. So to finish about context and introduction about MySQL, so currently at MessageBird, I'm working on service discovery and failover. So I am using proxy SQL to do this. Eventually, I hope to be able to do a talk about this. And obviously, MessageBird is using Orchestrator. This is one of our big deployment. The color coding is data centers. And we are in Google Cloud. So now we'll go about the war story. So we'll set up the stage for the MySQL master and slaves where things bad happen. We have a very simple deployment here. So even if it's simple, things can go wrong. One master, that is A, a slave in the same data center, B, an intermediate master in another data center, X, and another slave, Y. It's very hard to have more simple than that if you are on two data centers. And the first thing that happened is that both A and B failed at the same time. And it wasn't a whole data center failover. I'll come back to why this happened a little later in the talk. So we can't read and write to the master. We can still read from Y, but this is bad. Orchestrator detects that and fixes things. So now we have DNS pointing to X. Orchestrator did the right thing, and things are OK. We have the write and read from the master service is now restored. So after that, so a few things happen in that day and in the night. And I literally woke up to this on Saturday morning. DNS points here. And reads are still happening there. So just think a few seconds about why this is bad. Because it's pretty bad. So X was promoted when the first incident happened, so we started writing there. And something made DNS point to B. So now writes are happening on B. But B is outdated. All the write that were done on X were not done on B. And now all the writes that are done on B are not read on Y. So that's a pretty bad situation, like not a good weekend. That will be tough. So that's the disaster. So we don't yet know what happened. So we fixed it, and then we tried to understand what happened. So in our logs, what we have is A failed, everything was done well, but then Orchestrator is reporting another failure, a second failover. So what actually happened is that A and B, after being down, came back. And like they were there, alive, not doing anything. Something caused the failure of A. And so Orchestrator, at that moment, said, OK, I need to failover. And it called the DNS Repointing script. And that script stole the DNS entry from X and made it point to B. So we ended up in this situation. So now we understand what happened. But we still have an unanswered question is, what made A fail? And so once we're like this, A and B had outdated data. And that wasn't cool because at that moment, I didn't have any database on the left data center. So I was a little nervous here. And we needed to restore database there. So my first plan was to reslave B to X. And that could have been possible because if B didn't receive anything from A, so if A stays down and B comes back up, and if I'm lucky enough that there's no transaction on B that were not seen on on X, I can still put B under X, and I'm able to salvage B. But this didn't happen. Both servers came back up. And there are things that are happening in the MySQL world, like us DBA, we like to have things that monitor our database. And on the master, we have an event scheduler that push things to the database. So when they came back up together, they started to have new data that wasn't on the right part. So at this point, B could have been restored from backup or from another copy. But A was restored instead. And that's human error number one, and it's my mistake. And so here I have a plan. I had a plan to salvage B and reclone A, and I didn't adapt correctly to the new situation. So I didn't change my plan. So there's probably a name of a bias there. I would say like it's a pre-planned thing that I didn't adapt well. So this is error number one. But when I did that, Orchestrator didn't fail over right away. If it would have, we would have known it, and I wouldn't have woken up on Saturday on this. I would have known that on Friday afternoon. So B was promoted hours after the recloning started. And this is human error number two, and it's also mine, is that I downtimed A for 4 hours, and at that moment, I armed the ticking bomb in Orchestrator to fail over 4 hours later. So this is human error number two. So Orchestrator has some features to avoid flipping and failing over systematically. So there's an acknowledgment feature in Orchestrator. Orchestrator will not fail over again if you don't acknowledge a failure. And here, there might be a human error number 0, which is not mine, and this is where I have a harder time saying if, like, I don't want to blame the person that did that, but maybe acknowledging this was not the best thing to do. We were not yet in a complete stable situation. And also, Orchestrator failing over the second time might be something in Orchestrator that shouldn't have happened. I think none of us here would have actually manually triggered that failover. For two reasons. It's old and infrastructure, that was useful before and it's not useful right now, so we don't fail over there. And I'm pretty sure none of us would actually triggered a failover when something gets out of downtime. So here, there was something that could be improved in Orchestrator. So in summary, those 7 things happened wrong here and caused this disaster. There was a fancy failure. There was maybe a premature acknowledgment. There was an edge case recovery. The fact that when we start MySQL, we start A as live, injecting things could be also some part of this. Recloning was done wrong. So A instead of B. Maybe recreating this as immutable infrastructure, recreating new servers there would have been a better idea. And I would encourage you to do that, reprovision new server instead of touching the existing. Maybe you can't do that if you're on fixed hardware. And also too short of a downtime for recloning, so this is all part of recloning wrong. Orchestrator failed over something that it shouldn't have. And we had that DNS repointing script that didn't check if the previous master was what it expected. And I really want to insist that 7 things went wrong. You remove any of those things, we don't have a problem. So I liked the keynote on the first day where we talked about a system problem. There really is a system problem here. And I never thought about this way. And when I present that, a lot of people are saying, oh, that's just the DNS repointing script that's a problem. And I say, no, there's a bigger problem here, and we should address that from more than one angle than just fix the script. About that fancy failure, and that's very interesting. So why 2 servers failed at the same time? And I'm saying at the same time here. I'm not exactly sure they failed at the same time. Maybe B failed before A. I don't have the logs to check now. So is it a deployment error? 2 servers being in the same failure domain, in the same rack, or on the same power supply? Or were we very unlucky? And it happens that we were very unlucky. On that day, 10 to 20 servers failed in that data center because people were working in the data center and hardware was a little sensitive. So the exact work that was done is some blades were swapped in a blade center. So for you who do not know what a blade center is a big chassis with many servers that are racked in it as blades. And you remove a blade and you put another one. That is an operation that shouldn't be problematic. But if you push a little too hard on the blade, the back plane bent, and it has a probability of disconnecting the adjacent blade. So it's a failure mode of the blade center. I'm not sure it's that. There's another failure mode of the blade center is if you have older chassis which has less power, and you forget about the few chassis that have less power and your new chassis have more power, you put too many servers with too much RAM in those old blade center, and then you go above the power output of the blade center, and then it shuts down random blade. I actually think it's the first one, the bending of the backplane, because this explains something that the DBA team at my previous employer, something that we saw is we had some blades that are dual blade. The CPU was on the side, and there were disks on the other side. And quite a few times, we realized that the database failed. We were able to SSH the server. Everything was fine. But the other blade, like the disks were gone. Linux was still working because the Linux disks were on the first blade, but the disks were gone. And it happened a few times, and we were not understanding why. And now our best guess is the adjacent blade was moved, and then the backplane bent, and no power on that blade. So fancy failures of hardware. And now, how can we fix such situation? So you end up having data on B and on X. So there's two solutions. Either you drop one of them, and you say, I'm going to lose half of the data, or you replay the writes and all the updates, and that's complicated. I tried to replay stuff. I like replication. I understand replication very well, so I tried to use replication to fix the data. And then I had a problem. Auto increments were in the way. Because what happened is, let's say we were at auto increment number 100 on A. Maybe up to 99 were replicated on X. And then those, like X, when it started to write on it, started from 99 and so on. When A and B came back up, 100 went on B. And when the writes happened on B, it started again, 101, 102, and so on. So now we have two rows that have the same ID, but it's not the same data. Not in that situation, but it can be even worse that you have a reference somewhere in another database to that row, and you're in trouble. So since that day, I don't like auto increment very much. I tell people to use something else, and the solution here is to use UUIDs. So it's the last part. UUIDs are more interesting than auto increment because they are not allocated by the database. So you do not have a single point of failure that is allocating your IDs. But there's a problem with auto increment, not auto increment, but UUIDs, is that V1 UUIDs, every time you generate a UUID, pops up about randomly in the UUID space. So it's a very different behavior than auto increment. Auto increment always happen at the end and have a very nice locality. So to be able to use UUID almost the same as auto increment, you need to shift the bits, the timestamp bits in the UUID to put them all at the beginning, and then you generate UUIDs in order. And MySQL likes that better. There's two links about how to do that. And when I say MySQL likes this better, actually it's InnoDB that likes this better. If you use a different storage engine, it might not be the case. So takeaway, well, twisted situation happened. Like that was a very, very twisted situation. Automation is something that needs to be maintained. It's the subject of the previous talk, but also needs to be developed very, very carefully. Like if you try to develop automation too quickly, something wrong will happen. So spend extra time in automation, validate precondition, make sure it stops doing things if the state of the system is not what the automation expect, and like do more of validation than less. If you have a manager that is pushing for automation too quickly, like this is a recipe for disaster. Since then, I'm quite mindful about premature acknowledgements. I also downtime way more than less, and instead of letting the downtime expire, I undo the downtime myself. I shut down slave first, and all that boils down to understanding the complex interaction in a system. So it goes back to the second keynote on Wednesday. Like treat the whole distributed system as a system and understand things a little better, because like the interaction in all that complex system can fail in very weird ways. So to wrap up, master failover does not always go as planned because it's quite complicated. So it's not a matter of if things will go wrong, like one day things will go wrong, so be somehow a little ready for that. And in this case, using UUID instead of auto-increment would be a way to be more ready. Knowing what you will do if you end up with a split brain on your data is probably something that you shouldn't spend too much time on, but at least a little, because like this happened on Saturday morning. If this happened at 3 in the morning and this needs to be fixed very quickly, it's better to have a plan. And the last thing, please share your war stories. I think we learned a lot from each other in our war stories. And GitHub did that. They had quite a big outage a few months ago, or actually a year ago. And it's very nice of them to have put a full postmortem. More and more people are doing that. I'm on stage today to share that with you. We should do that more. Obviously, MessageBird is hiring, and I now have time for questions.
So you mentioned that one of the things you've taken away are like a greater awareness of the subtleties of all the interactions of all of these systems. Have you thought about, or have you done anything to make it easier for other people who are not yourself, who have like a deep knowledge of all of this stack, to be aware of this, right? Presumably you're not always the one on call. Like, what's the story for spreading that knowledge and systematizing it?
I don't have a solution for that. So complex things fails in complex way. The name for that on the keynote on Wednesday is emergent behavior. I think that qualifies as an emergent behavior of a system. I think we could discuss more, and the other person, in terms of system analysis, can help us more. I just did the link on those things during the conference. So I think it's treating things as system, looking for emergent behavior. I don't have a solution to train people for that. Other questions?
I had a question. Do you think that this automation had too much power to do too much in your production systems? Should it maybe not have been able to do 2 failovers in a short period of time, or something of that along that nature?
Yep. So Orchestrator has a fail-safe to not trigger failover too many times. And an example of that is if you have an application killing a master, like doing a bad query, and then Orchestrator fails over, and obviously the application is still there, it will kill the next one, the next master pretty quickly. So Orchestrator has a fail-safe mechanism there. Orchestrator also have a big red button. So if it starts to trigger too many failure, like if you start to have a lot of problem, if you're in the cloud and all your VMs start to fail because your cloud provider has a problem, you probably want to stop Orchestrator there. But the first failure happened on a Friday afternoon, and the second one happened in the night from Friday to Saturday. So we're quite far apart there, and this is where I'm saying about the error, the human error number 0, like the acknowledgement there, where if that wasn't acknowledged, Orchestrator might not have failed over. So there's too much distance on those two events to talk about power of automation. Some people do not like to automate master failover in MySQL. because of those problems. But when you start to be at scale, you need to do it. Like when you're GitHub, Facebook, Booking.com, MessageBird, you need to do that. And yes, it's hard to do well. Challenging. Other questions?
I was just wondering about the Orchestrator UI and whether or not you feel that it's a good idea or a bad idea to have drag and drop for that interface.
I'll just put back the UI so people can understand it. Yeah, so we can drag and drop things. So an example is here we can drag this on this to change topology of replication. I prefer to do that in Orchestrator than have to log on MySQL. So because this is something I sometimes have to do. So I like that it's there. Needs to be, this is a right you don't want to give everybody. And in Orchestrator, there's a way to, there's two types of user in Orchestrator. Orchestrator doesn't manage user itself, but there's two flags you can have on user, like read-only and read-write. And the read-only user can only see what's there. I think it's a good balance to allow people to see what's there, but not mess up with it, and give read-write access to like the user that know what to do. But you obviously have scars about drag and drop. Like maybe you can either share it now or with me later, and we can discuss that more.
Got time for one more question? No.
Have you thought about having two masters in some sort of active-passive mode? And maybe, I'm not sure if that's compatible with Orchestrator.
So I wouldn't describe active-passive. Like there's another high availability solution for MySQL that is active-passive, and it's shared disks. So if you have an active master that is writing on disk, and you have a passive server that is not running MySQL, if this fails, it gets the disk back, and then you load it up. Like that would be what I call active-passive. In this case here, I would call that active standby, because those two here are actually standby masters. And maybe this is what you call passive. Failing over to a slave is active standby, but I'm not sure if I understand the question.
Yeah, basically, yes. But I was more thinking of what we did as a solution was to have a load balancer before the masters, and then in case of failure, we would fail over on the load balancer of the master. Then you would have to reslave his slaves to the other master, but
yeah, so there's in this situation, there's a solution that we often see in the MySQL world that like you shouldn't use. Like friends do not let friends do that, but I will mention it. It's cyclic replication. You have a master and you have a standby, and they replicate both ways, and then you have a load balancer on top of it that's active, passive, and if it fails here, it goes back there. Like that's okay if your load balancer never fails back, because you don't want this to flap. And it's also okay if you have the master with the load balancer here, the standby here, you replicate this way, but you don't replicate this way. You just replicate one way. You have an active standby, passive. The load balancer will fail only in what direction, and then it's a human that needs to restore a backup on the other side, activate back the load balancer, telling the load balancer now, Now my passive is my master, and now because everything is fixed, you can enable failover again. That would be a solution, but the load balancer here must not flap, and the standby must not replicate back from the master. If I didn't answer the question, feel free to come back to me after we're done.
Okay, thank you so much. Final round of applause for our speaker, please.